My name is Michał. I'm lead developer of Scylla Manager. And today I'm going to tell you how it can save your time by automating cluster operations and maintenance. As you probably know, there are other tools that can do similar things. So what's special about Scylla Manager? So first, it's built from ground up for Scylla, and it's completely aware of cluster topology. For every token, it can tell to which shard and node it belongs to. This gives possibility for optimizations to tasks such as repair that make them more robust and easier to handle by the cluster. Second, it uses Scylla REST API directly, so there's no JMX or parsing node output involved. Third, it has no agent or sidecar running on Scylla nodes. Instead, it uses SSH tunneling to securely access your cluster. OK, to better understand how it works, let's see a diagram. Can you see the little blue Scylla monsters? So each monster represents a Scylla node. On the right, we have clusters operated by Scylla Manager. And on the left, we have Scylla Manager stuck. When you install Scylla Manager, it comes with a local dedicated Scylla instance that is used as a database. But you're not required to use that. You may decide to store its data on a remote cluster. This is little blue monster on the left. Scylla Manager consists of two components, the server and a command line tool called ScyTool. Server exposes REST API that's consumed by ScyTool. And ScyTool is intended to make using Scylla Manager easy. It provides bash completion for commands and flags, and most of the time shows data as ASCII tables. If you need to access REST API directly, we provide a Swagger definition for that. In addition to that, Scylla Manager integrates with Scylla Monitoring, and we provide a Grafana dashboard to show progress of your jobs. OK. Security, resilience, and ease of maintenance. We achieve that by communicating with Scylla nodes using REST API over SSH. By default, Scylla binds REST API to localhost, which prevents from accessing it from other hosts. To overcome this limitation, Scylla Manager can work with Scylla nodes using SSH. And this has a number of benefits compared to other approaches, such as sidecar approach that you can find in other solutions. Most importantly, Scylla nodes are not modified. So there are no configuration changes, no software is installed. You don't have to run anything. You don't change your environment. And one caveat to that is that you have to distribute SSH public keys. And if you think about it, distribution of public keys is a surprisingly hard problem that spies have always faced. But luckily, there's always someone to lend a hand, and similar with Scylla Manager. In previous versions, client found it difficult to distribute those SSH keys across cluster, and now we have a script to help you with that. Scylla Manager SSH setup is a bash script, and you can audit that if needed. It would generate RSA key pair, discover cluster topology, and for each node, create a dedicated system user and copy public keys. It requires that you have access to a sudo-enabled user in order to perform all the operations. So in this example, it would generate Scylla Manager PEM and Scylla Manager PEM.pub files, the private and public key respectively. And on the nodes, create a Scylla Manager user and create a public key so that you can SSH it. There are two modes of operation. Either you can specify a list of hosts that you want to set up, or pass a discover flag to set up the full cluster, like that. So with a single command, it would go over a full cluster. OK, once a cluster is prepared, you can add it to Scylla Manager. It's fairly straightforward. All you need is hostname or IP of a node and the SSH credentials, right? In addition to that, you may add a name. Scylla Manager references clusters by a generated UUID or a name. If you don't give a name when creating a cluster, you may always add or change that later using scytool cluster update command. OK, let's see what Scylla Manager can actually do once the cluster is added. So the current version we have is version 1.2. It consists multi-DC repairs and ships as Ubuntu Debian packages in addition to RPM packages that we had ever since. We're working on version 1.3, which has a CQL health check, which would trigger alerts whenever CQL is not available on a node. The health check method is lightweight and secure. We connect to a node, ask for server options by sending options frame and wait for supported frame. And this way, this whole solution is database credentials agnostic and works out of the box. It's a small feature, and I think that this version would be ready anytime soon after the summit. The next big feature is recurrent backup and restore. We would provide backing up to S3 and local drive, throttling of transfer rate, compression, and encryption of your data. Basically, we're following the best industry standards on that front. In future, we want Scylla Manager to include Scylla monitoring to make installation and setup of monitoring even easier for clients. Scylla Manager would also handle scaling up and down your cluster, and it would provide a rolling upgrade and installation for Scylla. OK, so let's talk about Ripper for a minute. So we all heard eventually consistent like multiple times what it actually means. So if no new updates are made to the object, eventually all access will return the last updated value. The point I'm trying to make here that Scylla is a distributed database by its nature has to live with inconsistencies. And we fight them with hinted handoff or read repair, which I'll not cover here. But the last resort is entry-entropy repair that Ripper solves. OK, so someone could say that I'm using consistency level of quorum and what can go wrong. So let's consider the following example. Given replication factor of 3 and consistency level of quorum, once I delete something, Cassandra and Scylla, instead of deleting, insert data. And what the data being added is a deletion marker called a tombstone. A tombstone has expiration time, the GC grace seconds. And after that time, it's being removed or garbage collected, if you like. And what happens here is that when the tombstone is propagated to 2 out of 3 replicas, the client is notified that the operation succeeded since quorum was reached. But the other node may never get the tombstone due to network partition or like a myriad of other problems. And after GC grace seconds, when the tombstones are deleted on the other nodes, the node that did not receive a tombstone may still have the old value. But the problem now is that the old value is now considered new data and may start propagating to the other nodes in the cluster. So running Ripper is an important part of maintenance of each cluster, right? And a common tool to run Ripper is Node tool. It's distributed with Cassandra and Scylla. You find it on every node. And while you can run Rippers with Node tool, there are reasons why Scylla Manager should be preferred. The slide contains much information, but the most important is that you can schedule cluster-wide repair fairly easily. So you don't have to go to each and every node. You can also monitor progress of your jobs using a Grafana dashboard or scytool or CLI. And you can also pause and resume repairs, so you don't have to start from scratch. Last but not least, Scylla Manager strives to make as little impact on the cluster as possible. And this is done by splitting work into very small chunks and never issuing repairs that spawn multiple shards. Sorry. Okay, let's see how you can actually issue repairs with ScyTool. So there are two modes of operation possible, ad hoc and recurrent. The former would run repair once, while the latter would run in fixed intervals. You can specify start date in two formats. Either you specified a full date, or you may use a relative format, now plus duration. For that, hours, minutes, and seconds are possible, and you can mix and match those. So now plus 3 hours and 3 minutes is perfectly valid start date. With iflag, you may specify the interval, which in case of repair should be every 7 days, or at least less than 10 or whatever you have for GC grace seconds. We support multi-DC repairs, and you may specify data centers that you want to repair using glob patterns. Those are like regular expressions, but much simpler. And DC flag accepts a list of those patterns. This is compatible with plain enumeration, as you can see in the first example, but also supports exclusion with exclamation mark prefix. Similar with key space and table. So key space pattern is separated from table pattern by a dot, but you still have all the other functionalities as you have in DC. So this allows for pretty efficient specification what shall be repaired and what shall not be repaired. The other thing that I think is really important is that those expressions are evaluated on repair run. So whenever a key space is added or table is added or removed, it's going to be picked up by the pattern and it's going to be included in the repair. Okay, so glob patterns are not only limited to asterisks, but also support question marks for matching any single character, or some simple character matching is possible. I was surprised to find that this standard was added in 1969 in the very first version of Unix. It's still very up to date. Okay. Going back to ScyTool, you may also specify more precisely what you want to repair. Namely, you may specify a host that you want to repair, and in the other host that you want to repair that host with, as well as token ranges or kind of token ranges, like primary token ranges, non-primary token ranges, or like all of them. So if you specify all the three flags, you're going to repair like intersection of tokens that are contained by all the hosts. This may be handy in certain situations where a node broke, but please use that with caution. It's not the default thing you want to experiment with. Okay, we have a Grafana dashboard, as I said. You can see that in a booth, but it shows the progress. The same information is available from ScyTool, the command line tool. And in the Grafana dashboard, you can dig down into individual key spaces, hosts, or even shards to see like, progress in detail. Okay, let's see a little demo prepared by my colleague Henrik. Okay, let's click to play. Right, thanks. So here we add a cluster. And you can see that the cluster was added in the listing. Like I said, we print most of the time ASCII tables. We scheduled a repair for There's a certain grace period when the task is added and before it actually starts executing. It's like a few dozen seconds. Okay, and now we can see the progress, detailed progress from the stool command line. If we had a Grafana dashboard, it would show the same information. You can see segment count, segment success, and segment error. So the token range is split into like multiple small chunks called segments, and we repair one segment at a time. We can stop. Okay, and you can see that it's like stopped. And start it again. And as you can see, we continue where we left off. Okay, this movie like continues until it's completely repaired, but I think we can move on with the presentation. Okay, so Scylla Manager provides efficient and flexible repairs. Soon it will provide backups and restore. It's used by our enterprise customers, but now it's available also for open source users for small clusters up to 5 nodes. So go and download it and give it a try at ScyllaDB.com. Okay, thank you very much.